All right, ladies and gentlemen, we're going to get started with Chapter 5.1. This is composite functions. We did some stuff like this in Chapter 2 when we did functions. Our goal today is we're going to form composite functions and then talk about the domain of these. So a composite function is just basically taking one function and inputting it into the other. This is one way to write it. This reads f of g of x, and this is another way to write it using different colors here. All we're going to do is we're going to take g of x and put it into f of x. And this one reads g of f of x. We're just taking the g function, and then inside of it, we're going to put in f of x. All right, so as we take a look, we're going to evaluate these guys, and you guys have evaluated before. And again, when I'm doing f of x, I'm going to use this blue color. And when I do g of x, I'm going to use this little purplish color, red color. So the first thing is we've evaluated f of 2 before. Again, normally it's f of x. This is our x value. We go ahead and plug that in anywhere that we see an x. We're going to plug in that 2. Again, as we're doing that, please excuse my dear Aunt Susie, or Sally if you got a Sally. And go ahead and simplify. We got 2 times 2 squared, which is 4, and then minus 3. And we know that's 8 minus 3, which is 5. So take a second, do the same one. We're going to do g of 4. So we're going to take that function 4x, and we're going to plug in 4. So we'll go ahead and take 4 times 4, we get 16. Right. Now we're going to evaluate the composite function f of g of 4. So again, I like rewriting it in colors. I think that helps as you guys take a look. So I've got f of g of 4. Well, we know what g of 4 is, so it's like cover it up and input 4 into g. Well, we did that up here. G of 4 we said was 16. Now I want to take my f function, which is 2x squared minus 3, and rewrite it. So it's 2, our input squared minus 3, and this time our input is 16. And then we go ahead and simplify that. Go ahead and take 16 squared, multiply by 2, and subtract 3. You can use your calculator to do that. You should get 509 when you simplify. So last but not least, go ahead and try g of f of 2. Again, we're going to take that f function, and we're going to plug it in 2. Well, we already did that up here. Just kind of cover up, plug in f of 2, and we got 5. So we're basically taking the g function now, and we're going to plug in 5. Well, the g function says I take 4 times my input. And my input this time is f of 2, which again is 5. And 4 times 5, we know is 20. Okay, so again, you're working inside out. I like to cover up the number and figure out what that input is. What's g of 4? Once I know g of 4 is, I put that into the f function and then simplify. And then vice versa on the example 2. All right. You guys want to see that one more time? Here's 2 new functions. I got a new f of x is 4x squared plus 1, and now I got g of x is x squared minus 2. Well, this time I'm doing f of negative 2. So I'm doing f of negative 2. So again, this is where I like to cover that up and figure out, well, what's f of negative 2? So if you want to, we can do that up here. F of negative 2. We have 4x squared plus 1. And plug in negative 2. You guys can go ahead and simplify that. That's 4 times 4 plus 1. And again, that's 17. All right, so I'm going to take that 17. I'm going to go ahead and input it in right here for f of negative 2. So now I'm finding f of that 17. Again, we're using the f function. The blue guy here says I take 4 times my input squared plus 1. Now, again, my input this time is 17. So 17 squared times 4 plus 1, you can input it all in your calculator. You should get 1,157. All right, so go ahead and try that next one. We're doing g of 1/2. If you want to rewrite it, that's g of 1/2. Again, cover up the first guy, just work inside out, and we got to find g of 1/2. Seems super scary, but it's not too bad. I can go ahead and do that in my calc, or I can use function up here. The g function says I take x squared minus 2, my input squared minus 2, and down here my input is 1/2. So I can go ahead and plug that in. 1/2 squared is 1 squared and 2 squared, which is 1 over 4, and then minus 2. And my final answer is -7/4. Again, if you want to leave that as a decimal, that's fine too. Whatever helps you. Now I'm going to put that into my function. I've got g of 1/2, and we said g of 1/2 we found to be -7/4. Again, the g function says I take my input squared minus 2, and this time my input squared is -7/4. Again, this is something, if you want, you can plug in your calculator. You can take -7/4 squared minus 2. You can do it in your head. You'd get, what, 49/16, and then minus 2. And eventually you should be able to simplify that to 17/16. And if you're going to do it by hand, you would need a common denominator. Multiply top and bottom by 16 to get that. 49 minus 32 is 17/16. So as we take a look, we're going to do the exact same thing. Here we have two functions. I have y is f of x here. I'm going to trace this guy out in blue. Hopefully you can tell I'm using different colors here. And then we've got g of x here is this curvy one. All right. And again, they're giving us a bunch of different quarter points on this graph. So the first question is, okay, example 5. F of g of 3. Can we work inside out? I like to color code this guy, g of 3. Well, they're saying, hey, what's g of 3? What is that? And again, the big idea is like they're saying, hey, x marks the spot and x is 3. What's the y value? Question mark. What's the y value? So this is where we go to our g function and we got to figure out what's the y value. So when x is 3, we find out where that treasure chest is. There it is, right there. We get 3 comma 1. So g of 3 is 1. Now the real question is, well, what's f of that? What's f of g of 3, which is 1? All right, just plug in 1 right there. Well, now this tells me, hey, the x value is 1 on the blue function. What's the y value? So this is where I go back to the blue function, and I got to figure out where it's 1. Well, there it is right there. When x is 1, the y value is -1. So that's your final answer. F of g of 3 is -1. Okay, let's try that again. Again, we're doing f of g of 1. So again, cover this guy up and work inside out. So the first thing we have to do is figure out what g of 1 is. They're saying, hey, the x value is 1. What's the y value? Question mark. So again, we go back to the pink function. We got g is right here. So find 1. Oh, there it is. G of 1 is 4, the y value. Now we can figure out what f of that is. Again, g of 1 is 4. Go ahead and plug in 4. This tells me to go to the blue function, the f function, and find 4 for the x's. I don't see 4, do you? Oh, right there. That's again an x-intercept. When x is 4, what's y? Well, that's a corner point, 4, 0. All right, so last one is just backwards now. It's g of f of 7. F of 7. Again, work inside out. The first thing I would do is find what f of 7 is. So they're saying, hey, x is 7, what's y? So now we go to the blue function, the f function, and we find 7. Oh, there it is right there. So we get 3. Now we're going to go ahead and plug that in and figure out what that is. So now I've got g of 3. Boom. Plug it in. There it is. G of 3 is 1. They're saying, hey, x is 3. What's y? On the pink function, there it is. So again, we're working inside out. It's like a treasure hunt. You got to know what map you're looking at. Are we looking at the blue map, the f function, or are we looking at the pink one, the g function? They're telling you what x value you're looking at, and from there you got to find the y value. And then sometimes you have to do it again on the other function.
Now we get into the algebra. It says for the given function f and g, find the composite functions. Okay. State the domain of each composite. So I've got f of x equals 3x plus 1. So if you don't have your notes, hopefully you're writing this stuff down. I don't know how you learn this stuff if you don't write this stuff down. G of x is x squared. Okay. Well, they want us to find f of g of x. Now, this time I have an x there, so my answer is going to have an x in it. They also want us to find the domain of this final composite function. So to do that, I always go through and make sure I know the domain of the original functions. Okay, this guy's a line. It's a type of polynomial function. There is no denominator like I see down here. There's a denominator, so those would be restrictions. I don't see any square roots, so I definitely have no restraints here. I have no denominator, no square root. I have no restrictions. So my domain would be the all reals, the fancy R. Okay. Same thing with this one. I have a quadratic here. I have a parabola, right? There is no gaps, holes, or breaks in a quadratic or a parabola. So your domain would be all reals, or you could write it negative infinity to infinity, however you want to do it. I don't really care. I think in my math lab, it'll just be one of the options to choose with a multiple choice. So let's get started here. All right, it says f of g of x. So let me write my f's here. So f of g of x. Well, g of x is x squared. So I'm doing f of x squared. Well, the f function says I take 3 times my input and I add 1 to it. Okay, so if this was like 10, if this was f of 10, I would plug in 10 right there. But it's f of x squared, so wherever there's an x, I put parentheses, and in my parentheses, I put the x squared. So if there's a 10 here, I'd plug 10, I would multiply and simplify. Well, it's f of x squared, so I put the x squared in there, I multiply and simplify, and I end up with 3x squared plus 1 is my final answer. Again, when I look at this guy, there is no denominator, there's no square root, so your domain is that fancy R, the all real numbers. You got to be able to give me the domain of that composite. Any questions on how I got 3x squared plus 1 or my domain? Sometimes they're just super easy. So far, so good? All right, let's look at number 9. Now I'm doing g of f of x. So when I do g of f of x, I like to write this way. I just prefer how it looks. To me, this makes more sense. I'm doing my input is f of x, which is this guy. I got 3x plus 1. Okay. If I look at the g function says take my input and square it. Okay. So if my input was 3, I would plug 3 in here, I'd square it and be done. Right? I would get 9. But that's not my input. My input is f of x. It's 3x plus 1. So I got to take 3x plus 1 and I got to square it. Okay? Well, it's been a while. What's that 4-letter F word you're allowed to say in math class? What can you say in math class? Foil. Foil, yeah, baby. Boom. So if you need to expand this out, 3x plus 1 and 3x plus 1, and then go ahead and FOIL that thing. Okay, 3x and 3x, that's 9x squared. 3x and 1 is 3x, do it again. Now I got 3x and 3x, that's 6x. And 1 times 1 is 1. Look at that. Again, we got a nice quadratic here. There is no denominator, no square root, no restrictions in the domain. So your domain is that all real numbers. If you want to write it like this, you want to write it out, all reals, you can do that. It's kind of whatever you want to do. You can do negative infinity to infinity. You can do whatever you want. All right. Do we have any questions? So you might, they might go through and say, hey, well, what's f of x? Well, that's just taking f of x and plug it in inside itself. So you would take 3x plus 1 and plug it in right there for this x. And then you would simplify. You would take 3 times 3x plus 1 and add 1. Or you might have g of x. You would take x squared and plug it in. X squared is x to the 4th, and you'd be done. So you got to see what they're asking you to do. Usually it's f of g of x, g of f of x, f of x, or g of x. You just got to see what they're looking for. Any questions on 8 and 9, y'all? So a lot of you guys are like, man, that's easy, and I don't need to see any more, but I want to show you these last two for sure, because now we're dealing with fractions. Okay, now this is where domain, really, we need to hit up on domain and make sure we understand it. Okay, so when we do domain of fractions, we definitely have some restrictions here. So again, I'm doing f of x here. In blue, I have f of x equals 2 over x minus 1. And g of x I have is 3 over x. So when I take a look, there's definitely a restriction here. What makes my denominator 0? What's your domain? All reals except for what? Mary's giving me the 1. Very good. So if you set x minus 1 can't be 0, right? Can't divide by 0 here. Add the 1 over, we get 1. Perfect. Okay. If I look over here, g of x, I have 3 over x. X can't be 0 either. Okay, so the domain of this guy, x, can't be 0. It can be anything, it just can't be 0. Poor Melody keeps on getting knocked out of here. All right, so any questions on my domain of my two functions that I'm starting with? So far, so good. I hope we're writing this down. Here we go. So I've got f of g of x. G of x is this guy right here. It's 3 over x. Well, if I want to do f of 3, I would take the f function, which is 2 over x minus 1. But instead of x, I would put parentheses and I would put 3 right here. But it's f of g of x. It's f of 3 over x. So I got to put the 3 over x right here. Okay? And now this is where domain comes in. When I do my domain, I got to do my domain of my input and my final output. Well, right now, if I was to check domain, there's a restriction with this guy, right? If you look at my input, the input has a restriction that x can't be 0. So my final answer is domain can't be 0. Because if I plug in 0 right now, this whole thing's undefined. Does that make sense? So when you do domain, check your input and your output. So there's a restriction in my input. Now, we want to simplify this, okay? You can't see me right now, but I'm shaking, all right? My head has a little nervous tick to me, all right? This is like a English teacher in reading one of your handwritten essays, and you're not capitalizing I, and you're not capitalizing the first word in each sentence, and you're not using punctuation, and they'd start shaking, okay? That's what's happening right now at the Gosh household. I got this nervous tick. I see a fraction, this little guy, inside this big fraction. I can't stand that. We got to simplify that, okay? So for us to do that, we need to get rid of this x on the bottom, okay? Now, this is something that your Algebra 2 teacher taught you way back in March, April, May, somewhere in there, and then ask yourself how much math did you actually do during the first quarantine. I can't answer that for you. You could, okay? But a little trick to simplify this guy is to multiply everything by the denominator. So if we have a denominator right here of x, the little trick, I'll use red here, is to multiply top and bottom by that denominator. Okay, so maybe make note of that, multiply by your denominator. Start that up. Okay, so I'm multiplying top and bottom by my denominator. When I do it to the bottom, I've got to distribute to every term. So I got to just basically multiply everything by that denominator. Okay. Now, when I do that, a little math magic happens. Doo-dee-doo-dee-doo. On top, I get the 2x. X times 2 is 2x. And here's the magic. When I multiply x times 3 over x, doo-dee-doo-dee-doo, these x's eliminate and just disappear. There's the magic. And now we get 3. And then minus x. Negative 1 times x is negative x. And that's my final answer. Look at that. So I multiplied everything by the LCD, which in this case is x. Okay. And x times 2 is 2x. Here the x's cancel. Leaves me with 3 and then minus x. Okay. Now to finish off, you're going to be asked for the domain. I have a restriction of 0 from my input, and now this is my output. This is my final composite. So I have to look at 3 minus x. That can't be 0 either. So when I add the x over, I get 3 can't be x. That doesn't make sense. That's written backwards, right? That's like Yoda. Our disease, the dark side is 3 cannot be x. Yeah, that's just crazy. It would be x cannot be 3. So x can't be 0 or cannot be 3. There you go. Was my Yoda impression pretty spot on or not so good? Do I need to work on that? Anna, do I need to work on that? No? Mary? Work on Yoda? No? Hard to see the dark side is. Oh, yeah. Oh, man. All right, all right. Any questions with that one, y'all? You guys got a real treat if you're a big Ahsoka Tano fan. You Star Wars fans, oh man, the Mandalorian, watch out. All right, let's do 11. We're almost done here, gang. Let's get her up. So when I take a look at number 11, I've got g of f of x. F of x goes in here. F of x is 2 over x minus 1. Okay, so the g function says I take 3 and I divide by my input. So if it was g of 2, I would plug in 2 right here. I'd get 3 halves, right? But it's not g of 2, it's g of 2 over x minus 1. Okay, well, right now, I have a restriction in my domain. My domain is all real numbers, except x cannot be 1. If I plug in 1 right now for my input, if I plug in 1, that's undefined, makes the whole thing undefined. So I can't have that. So when I do domain, I always do domain of my input and then whatever I get at the end. Okay? So, little trick here. I have 3 over 2x minus 1. If it helps you, you could look at it like this. Think of it as 3 over 1, and then divided by 2 over x minus 1. Okay, think of a fraction over fraction. If I have a fraction over fraction, I can multiply by the reciprocal. Okay, back in the day when I learned it, they said, don't ask why, invert and multiply. All right, so I can flippy flip this guy, multiply by the reciprocal, and that way these guys cancel. And I can distribute here. 3 times x is 3x, and 3 times negative 1 is negative 3. And 1 times 2 is just 2. So my final answer is 3x minus 3 all over 2. Hopefully you guys can see that. Finish up with your domain. If I look on the bottom, I don't have an x to solve for. That means I don't have any other restriction in my domain. I just can't have 1. So my domain is all reals except for 1, and that's from the input. The output, my composite function, had no restriction. Okay, but I have to look at my input and my output for my domain. Okay. All right, any questions? Now, there is other ways to solve that one. I'll just do it real quick here. So if you had 3 and then we had 2x minus 1, the other way you could do is just do what we did before, is look at your denominator, x minus 1, and multiply that top and bottom. So that these cancel, and then we just distribute. That gives me 3x minus 3, and then all over 2 is left. You got 2 different ways to look at that. Okay, you can invert and multiply, or you can just multiply by the lowest denominator. All right, ladies and gentlemen, before we get out of here, I do want to talk about number 12. This is a basis of where we're going, so I need to talk about this real quick. Number 12 is saying, hey, show that the 2 composites are equal. Show that f of g of x and g of f of x is equal to each other, which will equal x. All right, so I got to show you this real quick. So I'm going to do f of g of x. G of x is this guy right here, x squared, and f of x is the square root of x. So f of g of x, f of x squared, is just, hey, the f function says I take my input and I square root it. My input is x squared. When I square root something squared, I get what's inside, I get x. So I'm halfway done. I got what I wanted. And now I do the other way. I want to do g of f of x. F of x is the square root of x. Well, the g function says I square my input. Well, my input is this guy, the square root of x. And when I square root, I get what's inside, which is x. So I just showed that these two are equivalent to each other. When I do f of g of x and g of f of x, I get the same thing, which I get is x. Now, this only happens if these 2 functions are inverses of each other. Okay, and that's the whole premise of what we're going to learn here shortly in the next few sections. We're going to discover and look at exponential and logarithmic functions, and you'll see that exponentials and logs are inverses of each other, and that's actually the next section. We start talking about one-to-one functions and inverse functions. Okay, that's chapter 5 too. So, ladies and gentlemen, that's all I have for you today.